Welcome everyone to today's Explainer. I am so thrilled to guide you through this because we are looking at one of the absolute biggest mysteries of science, the origin of life. But, we aren't just looking at some random chemical soup today. Actually, we're exploring a fascinating, highly mechanical approach detailed in a comprehensive preprint paper by independent researcher Sergei Mamytev. It's called Snow Hypothesis 2.0, the quantitative thermogradient conveyor with cryoprotectant. We are going to unravel how the simple physics of a freezing cold environment might have literally built a microscopic, non-stop engine that powered the dawn of biology.
To really appreciate this model, we first have to pause and ask a fundamental question. How did life's fragile first building blocks survive long enough to actually build something complex? If you're familiar with the early Earth, you know it was just total chaos. You've got boiling heat that destroys fragile RNA bonds, and vast oceans that dilute chemical concentrations down to practically zero. So how on earth do delicate little precursors manage to not only survive, but actually concentrate and organize themselves?
Okay, let's dive into this. The Snow Hypothesis 2.0 gives us an incredibly elegant answer. It proposes a quantitative model where life's precursors were concentrated and organized precisely on the boundary of a warm mineral surface and a freezing cold, liquid snow environment filled with cryoprotectants. Think of this whole setup as a natural, pumpless engine. It's a system that perfectly balances the creative energy of heat with the preserving, concentrating power of extreme cold.
So, here is the roadmap for our molecular journey today. We'll start with the origin of life enigma, move right into nature's engine, explore the magic of cold, tackle chirality, climb the Eigen wall, and finally, look at the path to experiments. We're going to tackle these interlocking physical and chemical puzzles step by step.
Section 1. The Origin of Life Enigma, a multi-stage gauntlet. Modern origin theories recognize that you can't just throw a bunch of chemicals into a jar and expect life to pop out. It requires a very specific physical stage. Solving the origin of life isn't just one isolated problem, it's a brutal, multi-stage gauntlet that our molecules simply have to survive. You need monomer synthesis to build the bricks. You need concentration to bring them together. You need homochirality, which means getting all the molecules to face the exact same way. You need protection from thermal decay. And finally, you absolutely need a mechanism for exact self-replication. Most environments in nature might solve one or two of these, but they completely fail at the rest.
Section 2. Nature's Engine, the thermogradient conveyor. Let's introduce the physical space where our story actually takes place. Picture a warm mineral plate with snow falling onto it. This creates what's called a Marangoni thermocapillary conveyor belt. You get a hot core at about 60 degrees Celsius right in the center and a cold rim on the outside. Because surface tension naturally changes with temperature, the liquid is physically pulled from that hot center outward to the cold rim, and then it just cycles right back along the bottom. It is a non-stop, microscopic conveyor belt running entirely on heat differences. Pretty amazing, right?
Let's follow a single molecule taking a ride on this natural engine. Step 1. It passes through the hot core at 60 degrees Celsius. This provides the crucial energy needed for rapid chemical synthesis and activating monomers. But, importantly, it doesn't stay long enough to burn up. It gets swept right into Step 2, the warm zone, at around 45 degrees, where molecules assemble and lengthen on the mineral catalyst. Finally, the flow carries it to Step 3, the cold rim, at a freezing -40 degrees, where it undergoes cryoconcentration. Literally, every zone helps overcome a different chemical hurdle.
Section 3. The Magic of Cold and Liquid Cryoprotectants.
Now, this is where the 2.0 major upgrade to the Snow Hypothesis really shines. If you look at the older 1.0 models, the older cold edge was always assumed to be just pure water ice at 0 degrees Celsius. The problem there, ice is solid and chemically inactive. The 2.0 upgrade introduces a massive shift: the presence of glycerol and salts. Glycerol acts as a natural antifreeze, turning that icy edge into a slushy cryoprotectant solution. This means the water actually remains liquid and highly chemically active, all the way down to -40 or even -46 degrees Celsius.
Now, what's really interesting here is how this liquid cold solves the famous dilution paradox. As water slowly freezes out into pure ice crystals at the edges, whatever is left over in the liquid, our organic precursors, gets massively squeezed together. Molecules are concentrated by factors of thousands or even millions, shifting the whole environment perfectly into a highly productive chemical state. It literally forces the building blocks to interact. Section 4. Chirality, bypassing the mathematical penalty.
To build complex, lifelike RNA, you absolutely need homochirality. That just means all the building blocks have the same handedness, kind of like a chain made entirely of left-handed puzzle pieces. If your building blocks are a 50-50 mix of left and right, getting a chain of 40 identical pieces carries a massive, almost impossible mathematical penalty. But through a process called eutectic amplification in that cold rim, the ratio of left to right molecules can be boosted to 99%. This basically acts like a mathematical cheat code. By amplifying that chirality to 99%, you completely remove that massive penalty, yielding an advantage up to 4.5 times 10 to the 15th power. Suddenly, assembling long, functional RNA chains becomes practically achievable. No magic required, just math and cold.
And the deep cold does even more. Let's talk about survival. At 90 degrees Celsius, an RNA molecule falls apart in a mere 2 months. It just breaks down. But if that molecule rides the conveyor into the minus 40-degree glycerol rim, that half-life extends to hundreds of millions of years. It preserves the molecules perfectly, essentially pausing the clock, so they actually have the immense time they need to evolve.
Section 5. The eigenwall and rough correctors. Okay, so we've built the pieces, we've concentrated them, we've made them chiral, and we've preserved them. But now we face the most daunting hurdle of all: exact replication. The eigenwall is a famous paradox in this field. Basically, copying a molecule without a complex biological enzyme is really sloppy. If your copying process has an error rate of 10%, you can only build a sequence of about 10 to 20 building blocks before errors just completely destroy the chain's information. But here's the catch. To build a biological enzyme that fixes those errors, you need a chain of 100 to 200 blocks. You need exact copying to get exact copying. This creates a hard ceiling that normally halts the origin of life right in its tracks.
So the crucial point is how the 2.0 hypothesis resolves this beautifully. You don't need a perfect biological enzyme right away. You just need what the author calls rough correctors. Base pairing alone gives you a ceiling of about 26 nucleotides. But if a mismatched pairing simply stalls the chemical growth, it essentially filters out the errors and jumps that ceiling to 2600. If you then add the ligation of pre-checked shorter blocks, it leaps to over 46,000. These simple mechanical filters multiply accuracy exponentially, completely vaulting over the eigenwall without needing complex biology.
Section 6. The path to future experiments.
What makes this entire hypothesis so compelling is that it transitions straight from theory into an investigative reality. The paper lays out a strict, logical sequence of experiments. E0. Actually prove the physical thermal window with glycerol works on a plate in the lab. E3. Test if the cold cycles truly amplify chirality up to 99%. E4. Run the full conveyor belt and trace the molecules in real time. And ultimately E7. Measure the actual chemical rarity of finding a functional RNA sequence. This explainer is mapping out a highly testable real-world detective story. So we leave off with this really provocative thought. The physical environment proposed by the Snow Hypothesis 2.0, the Marangoni conveyor, the extreme cryoconcentration, the deep cold preservation, it shows that the mechanical engine of nature doesn't block life, it actually clears the path. The physics of the universe is already perfectly tuned to build it. The final wall isn't the environment, but the chemical rarity of self-replicating molecules. The engine itself works flawlessly. So, is the right chemistry simply waiting to be discovered in our labs right now? It really makes you look at a freezing winter day in an entirely new, life-giving light, doesn't it? Thank you so much for joining me to explore this incredible source material today, and keep questioning.